we offer for a
Hello. I think Jenny's been disconnected for a second. Oh, are you back, Jenny?
I am back. Sorry, I accidentally left the meeting, but now I am back.
All good. I was going to jab if I didn't hear you in a sec.
Thank you. So those of you who are joined, you have noticed who our special guest is today. Here's Mark Leon-Young. I will spotlight you so you can say hello.
Hello. I'm so happy to be here. I was lucky enough I'm so happy to be here. I was lucky enough to be invited to be part of putting this exhibit together in terms of consulting on it early on, because I've written several books about orcas, The Killer Whale Who Changed the World and Orcas Everywhere. And then I was invited to write the exhibit. So it is a pleasure to be in here and to be able to lead you through and introduce you to these amazing orcas. I think where Jenny is right now is where we started last week. And with that Slick and that Scarlet, two of my favorite J-Pod orcas ever. So she's about to take you into the next room here, and you're going to meet the other star of the exhibit to me. This is Rhapsody. And Rhapsody is also a member of J-Pod. And the best way to explain J-Pod is I feel like J-Pod, they're the royal family. They are the Kardashians of the whale world. They are the most photographed, most studied whales in the world. And what you need to know about Rhapsody, this is a real skeleton. This is not a replica. And Rhapsody's body was found near Courtenay several years ago. And the body was taken to shore, and the Royal BC Museum asked to keep the body. And this was a decision made before there was any plan to ever do an orca exhibit. One of the things that was really exciting to me as somebody who'd never worked with or for a museum was the chance to go back behind the scenes and see how many things the museum keeps. Just we've got a historical record, and Rhapsody was kept for the historical record. Now, Jenny right now is showing you something that blew my mind when I got to meet Rhapsody, which is you look at those fins, and I know intellectually that orcas are mammals, that mammals are related, but you see those fins and don't those look like fingers to you? Because they sure look like fingers to me. So it's kind of mind-blowing to see Rhapsody together. And I wanted to share something with you. Dr. Gavin Hankey, who's the person who is in charge of the bones at the Royal BC Museum, decided to show me how Rhapsody would be put together. And so I'm going to share a video that we made of Rhapsody being assembled. And let's see if I can share my screen properly and get this going. And just give me one moment. And
as Mark is getting that organized, everyone who's joining on Facebook, please put in any questions you have about what we're looking at today into the comment section, and hopefully we can get all those questions answered today.
Okay, hang on one sec. Just zoom in a tech mood. Now, are you seeing my screen? Yeah.
Yes, I am seeing the screen.
Fantastic. This is being right there, and that'll be Dr. Hankey, and I am getting lucky enough to assist in putting Rhapsody back. And how amazing this is. At the backbone of Rhapsody actually has scoliosis.
So Mark, it's a little bit hard to hear you when the music is playing, so maybe after the video you can let us know. Super cool. Sorry, we couldn't hear you over the music. So do you want to just say what you were saying while the video was going?
Yeah, I wasn't sure. Sorry, I thought you could hear me over the music because I wasn't sure how loud the music is. It's the magic of Zoom. But what I wanted to share is if that spine looked a little off, that's because Rhapsody has scoliosis, which is one of the reasons Dr. Hankey was so excited about getting Rhapsody for this exhibit. And one of the things that's sort of magic about the way the museum put this together is that you'll see that Rhapsody is chasing a salmon. And that is just what these orcas, what the southern residents do. So the resident orcas live primarily off Chinook salmon. They were kind of the perfect food group. And now Jenny's taking us over to show us all the different types of orcas. And these aren't just different communities. These are genuinely different species. The term used is ecotype, but essentially these are different species who have not interbred or mixed in the wild in hundreds of thousands of years. There are 3 different ecotypes just in the waters off British Columbia off the Salish Sea. You have the orcas of J-pod, K-pod, L-pod, and also northern orcas who are known as residents. And the residents are fish eaters, primarily Chinook salmon eaters. Then you get the Biggs orcas, formerly known as transients. These are mammal eaters. And these are the orcas, if you go, why are they called killer whales? They're called killer whales because if you've ever seen one of these mammal-eating whales in action, they really are the fiercest predator on the planet. I mentioned this last week. There is now recorded evidence for the first time of a group of mammal-eating orcas taking down a blue whale. And there's another subset of orcas, another ecotype in the waters off BC and Washington State. These are known as offshores. They are rarely seen, and the offshores primarily like sharks. They like shark livers. They go after sleeper sharks, and sleeper sharks are huge. And part of how these orcas were discovered was that occasionally you'd have orcas wash up on the shore with really terrible teeth, and they didn't quite look like the orcas we were used to. And gradually, scientists realized these orcas had terrible teeth because they were eating sharks, and they were a whole different ecotype. So 3 different types just here. And there are different ecotypes around the world, and they each have developed in different ways. Oh, a couple of my faves. So the South African orcas. Now, if you're a fan of Shark Week, you're a fan of sharks, you've probably heard about the African orcas who were just eating all the sharks in South Africa. Well, I'm working on a shark book right now, and I've started consulting with somebody who runs a shark museum in South Africa, and he's going, no, they're not eating all the sharks. He figures maybe they've eaten a few dozen, and it's only 2 orcas, 2 male orcas, who are named port and starboard because of the way their dorsal fins droop on either side. And they've basically figured out the same thing as the offshores here, that if you flip a shark upside down, you immobilize that shark. And that makes it possible for the orcas to eat their livers, which is where apparently not just all the nutrients are, but I'm guessing the orca's just like, yep, livers are tasty. And then we've got another set of orcas who are amazing. And these are the Argentinian orcas, who kind of rock my world because they have figured out a way to hunt on land. And Maga, which means magician, is the matriarch of these orcas. And she basically figured out she seems to lead them, so maybe she figured it out. Maybe orcas before figured out that if the sea lions are too close to shore, the orcas can jump up, roll down, and take the sea lions with them. There's a National Geographic documentary that was just released that talks all about the culture of whales, and they've actually captured an image of the orcas of Argentina going after sea lions. All I can think of with this is that at some point a sea lion was kind of going, nya, 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 we're safe, and they weren't. And scientists have recently discovered that there are some transient orcas, some Biggs orcas in BC who've also figured out how to do this trick, which is mind-blowing to me. Speaking of mind-blowing, we are on an orca brain and a human brain. Now, scientists Human scientists, of course, used to be very fond of saying that humans have the most complicated and the largest brains on the planet, and that's how we knew we were the smartest and bestest and everything species on the world. And then they started looking at cetacean brains. And if you look, that's an orca brain, that's a human brain. Which one looks bigger and more complicated? The orca brain actually has a whole extra lobe that we do not have. And that extra lobe covers echolocation and senses that we really can't explain. And echolocation is a shared sense. And Jenny's taking you over now to an illustration that I just love that shows how echolocation works a little bit. So basically, the orca is sending out signals from the orca's head, so from the melon, and those signals or pings go out and sort of view the world using biosonar, and they not only see and sense that salmon, but they're looking inside that salmon. So most fish move using something called a swim bladder, and it inflates, and the way it inflates determines how the fish moves. Well, that orca is kind of cheating in terms of figuring out where that salmon's going, because that orca can actually tell where the swim bladder is filling up and where that salmon's going to move before the salmon starts to move. The orca is looking inside that salmon's body, which is mind-blowing to me. So if you know the Marvel comic superhero Daredevil, basically orcas have the exact same superpower. And it is really, it's something we can imagine, but we do not have. Let's see, we're going over to some of the stats about orcas. Oh, we're going over the evolution of orcas. Now, I don't come from a scientific background, so this completely blew my mind, was the idea that that is what orcas evolved into and from. So orcas did something that truly blows my mind. They evolved onto the land to become these guys. And basically, they looked around, and all I can figure out is the orcas went, yeah, we're on land, no intelligent life here, we're moving around. So I love this chart because it really breaks down the evolution of orcas and their relatives and how different species evolved. Now, I can wrap my mind around the idea that orcas are related to hippos. That makes perfect sense to me. But you start to look at the other species and you start to look at what that little guy looks like. And I just find that fascinating. That's just one of those moments to me that where science just feels magical. And now Jenny's going over to the magical wall of facts, figures, and statistics to give you a sense of how big orcas are. So this shows the weight that these whales can achieve. And again, in that first gallery, you got the chance to see Ruffles, a huge male orca, and really one of the biggest orcas we saw out here and fell in love with. You're also seeing here the gestation period of an orca is 18 months. Gestation for orcas, birth for orcas is very difficult. And going back to Rhapsody, Rhapsody died basically in childbirth. Rhapsody was carrying a full-term fetus when she died, and necropsy basically showed that there was an infection from the pregnancy, and that was what caused Rhapsody's death. And that may have also been because of the amount of toxicity in our waters. And these orcas are among the most toxic marine mammals on the planet. And when Rhapsody's body was disposed of, it actually had to be disposed of the way you would dispose of toxic waste, which basically tells you we need to take a whole lot better care of the water out here, which is the theme or one of the key themes of this exhibit, Our Shared Future.
We have about 3 more minutes, so if there's anyone who has questions, please put that in the comment section. I do have a question. It's a common question we get, is if there is a lack of salmon, why don't the orcas go after a different type of predator or a different type of prey or a different type of fish? Why are they so particular about what they eat?
almost all species sort of evolved to become very specialized hunters. And if you look at the orcas here, Chinook salmon until very recently weren't just plentiful, they were huge. Like if you look at, we used to have salmon derbies in BC all the time, and the winning salmon 50 or 60 years ago would have been the size of a small person. The winning salmon a decade or 15 years later became, you know, 30, 40 pounds. Like basically, we ate their entire prey species. And if you, orcas took hundreds of thousands of years to become the perfect predator for Chinook salmon. And then in really about 100 years, we wiped most of them out. So evolution works quickly. Evolution does not work that quickly. So and also we haven't left a whole lot of other large fish out there for them to chase. So it's not like the Chinook salmon have been replaced by huge runs of other salmon. So really, humans aren't so great at sharing, and we're not so great at seeing the idea that uh, that all the salmon in the ocean aren't just for us to eat.
No, and we'll get into that a little bit in a couple of sessions from now. But unfortunately, we've run out of time. I was just going to quickly end on this to kind of show they spend a lot of time foraging. So especially if there's not a lot of salmon, that goes up even more, that they have to go and try to find that food.
Foraging means looking for food. And
yes.
they shouldn't, I'm guessing they did not spend 60% of their time foraging when these oceans were full of Chinook salmon.
Exactly. Well, thank you everyone so much for joining us here today. We have 2 more of these coming up. If you want to know more about our digital field trips, there's a link up on the page right now and should be in the comment section on Facebook. We have different types of digital programming that you're welcome to book, from the Orcas tour, kind of like a little example of this one, to stuff about the gold rush, about the mammoth, a lot of other things. So please check that out. And if you have any additional questions, hopefully we can get to those next time. But thank you so much, everyone, for visiting us here at the museum, and we hope to see you next week. Take care, everyone.
All right, thank you.